In the previous part of the module, we discussed geometric sequences. And if you recall, a geometric sequence is a sequence in which one term, or excuse me, the next term of the sequence is obtained by multiplying the previous term of the sequence by some common ratio. And this common ratio here is r. So the common ratio is some fixed quantity, and in order to obtain the next term, we always multiply the previous term by that fixed quantity. Well, these sequences can actually be summed up to an infinite series, and in this case, this infinite series would look like this. And if you notice, all we're doing is we're starting with n equals 1 here. So if n equals 1, we end up with r to the 0 power, which is just 1. So this is a times 1 for our first term. If n equals 2, n minus 1 is 1, and that gives us this exponent here. If n equals 3, 3 minus 1 is 2, and that's how we get this exponent, and so on. I could just keep going and going. The important part is, if this fixed ratio, so if this fixed quantity, that is our common ratio, is less than 1, so its absolute value is less than 1, then this series is convergent. And if it's convergent, then we know that the sum actually equals a divided by 1 minus our common ratio. And now, of course, again, I have to stress that the absolute value of the common ratio has to be less than 1. If that's not the case, so if the common ratio is greater than or equal to 1, then the series diverges.